there are a lot of features here on the board that has redundancy. For example, what if you don't really have this type of I2C LCD, and instead you have a different type of backpack, such as this type? So what do? The pins are not exactly the same. This one has, let's see, VCC on the top and ground on the bottom, and the other one has ground on the top and SCL on the bottom. So they're not pin compatible. If you connect this by mistake, you'll likely damage some components. So what I designed here is I have both. As you might be able to see here, there are 4 pins. The left column 4 pins fits exactly this type of backpack, and the right 4 pins, this right column here, fits exactly these. And these typically come pre-assembled with right angle headers, but if you bend them straight, they will actually fit exactly through these 4 holes. So that takes care of these pre-assembled backpacks. What if you want to use them? Well, you can use both. You just choose which one is the one that you use. And what if you want to use something else? For example, you want to use a different type of I2C chip. For example, this one, the MCP 26008, and this is used by Adafruit and some other makers. And you can certainly do that. You just pop the chip in here, and then the LCD has to be connected to these pins. There are data and control pins, and also power and ground. So you put some headers here, put your chip here, and also have a potentiometer to adjust for contrast. So it fits these different types of LCDs. There's also a breakout here for ground, VCC, SDA, and SCL, just in case you have just another type that I haven't really anticipated. You can still connect that type of backpack to the board using jumper wires, something like this. So regardless where you are on the planet, what your local or regional suppliers have, you should be able to use this board because of different types of components that you can use as alternates. And another type of alternate is this. So here is a rectangular area. Here's another rectangular area. So if you look at the assembled one, this top area is occupied by this green board. This is one version of a boost converter that takes a 3 volt, for example, and boosts that into 5 volt to power Arduino. So if you turn on your power switch, that's what it does. It powers Arduino by turning the 3 volt into 5 volt. So what if you want a different type, or you have a different type? So here's the footprint for another type. This type is made by SparkFun Electronics. So it only has 3 pins. It's easier to solder, although it costs a little bit more. The other one, on the other hand, is slightly harder to solder. There are these single pins that you have to break out from these male headers and try to hold that component in place to solder. So it's slightly more difficult, but it's also slightly cheaper. And this breakout is for real-time clocks. It works for both real-time clocks that are based on DS3231 and also DS1307. I don't really have an example of that, but the pins will fit. Other redundancies are, for example, this is actually for resistors to be soldered on. So one of these is actually for the backlight control for this type of I2C circuit to control the LCD. But if you're using a backpack like this, there's already control, and you don't really have to solder one of these resistors anymore. And you can also try this alternative. For example, the connections here. This one says I/O, and if you put a resistor here, what it does is the power is automatically sent to the rest of the board as you flip the power switch. But if you don't connect this, on the other hand, you can use one of these digital pins to actually power. So this PWR here, if you solder this resistor instead, you'll be able to power the entire system up and down using one digital pin. And the benefit of that is you can turn on your data logger by using that pin, and then do some data logging, and then you can turn everything off and then put your Arduino on sleep mode. But in order to harvest the most power saving, you have to modify your Arduino Nano. For example, this thing here, this is unmodified, so I didn't really have that resistor here to have an Arduino pin to control the power. So instead, I have a constant on. So in order to modify this, you have to flip it to the back side, and first you have to remove the 3.3 volt regulator, because there's nothing that would require that. If you have an SD card slot like this, there is an onboard 3.3 volt supply. So if you turn off power to this entire board, nothing will consume any power. And there's also other things. For example, on the top, these are indicator LEDs. They also consume quite a bit of power. So what I would do is I would remove the resistors next to the LEDs so that they won't turn on. These include power LEDs and also LEDs on pin 13, TX, RX if you wish to save more power. So this data logger can, in principle, when you're running on 2 AA batteries, say if you take data every 10 minutes, the 2 AA batteries will last you a couple of months instead of only a couple of days, if you practice all these power saving practices and also modify your Arduino Nano. So another thing I want to talk about is this. Here is a slot for 4-channel 16-bit analog digital converter. The 4-channel analog inputs are also broken out to the same pins as A0, A1, A2, and A3. So if you don't wish to have high precision analog inputs, you don't have to use this. You can just use the Arduino's pin to sense up to 4 analog sensors. But if you do wish to have high precision, you can drop in that module and solder on the backside. Adafruit Industry designed this board, but there's also compatible boards on the market that are costing a little bit less than what Adafruit sells. But this is what you get basically if you pop this one in, and you can run high precision analog inputs on all of these 4 pins. There are 12 pins here on the screw terminal block. 4 of them are analog 0 through 3, and then there are other 4 that are ground connections, and then the last 4 are 5 volt connections that are fused. So in case you make a mistake with the connection. Another feature is over here. There are 5 pins here that can get you connected to a 10 DOF or 10 degrees of freedom boards with 3-dimension and accelerometers, magnetosensors, gyroscopes, and possibly also a pressure sensor with temperature calibration sensor in it. So if you wish to use this entire data logger as a data logger plus sensor, you can solder that board onto these 5 pins. You can tilt your data logger, turn it around, and you can collect data, and you can strap it on your body. Take a roller coaster ride, have it record. So there are lots of possibilities with this simple device. And the nice thing about it is open source. So anybody that's interested, they can print their own board, they can secure their own components, and basically they can just do their own projects with this design. And if you want, you can make changes to the original design.